Hello, I'm Chandaban Kapoor. I'm an instructor for the course in Design and Analysis of Algorithms, both theory and lab. Normally, this is how I organize material for teaching and sharing with students. So, here is the theory part. This is the master folder where I prepare material, and then this is the folder where I put all the material which I want to share with students. So at the moment there are only these three files, course info and lecture slides of the first two chapters. Here is the link for accessing that material I just showed you. So here is a short URL. Suppose if I go to another browser and then just type in that URL, it will redirect to the Google folder I showed earlier. So this is the view a student is gonna get. And similarly, I have one more folder for lab. So this is the short link for that. So let's see. Right. This is the view a student is gonna get for the lab part. So I have some announcement documents and course info and one folder for each session of the lab. Right. Here if I go back to lab part, this is the lab part, and this is the one I shared with students. So let's start off with the first session today. So in the first session, we are implementing a very simple algorithm, mostly for the introductory purpose, which is sequential search. Right. So normally let me say something about the course. So we have about 13 sessions of 2 hours of each for the whole course, and this is about the first session, and this is how assessment is done as usual for every lab. Right. So for every lab, here actually you see a lot of files, but we normally share only a document file here which describes the problem definition for the lab, and so in this one we describe what the problem needs to be solved, and then with a precise input on output format. We are strict about the input on output format because we are basically semi automating the process of executing it, right? So we have a sample input output, and then the algorithm is also given for the reference, and some practice problems for the motivated students, right? So along with this document, we are approaching basically a three file way of implementing an algorithm. We could have done with a single C file, but the way we are trying to do here is we share this header file with the students. So this header file, let me open that, and then students are expected to write these two files. One is the client file, another one is the implementation file. Implementation file so this is the function we are declaring here, which is basically which acts as an interface, and the students are expected to implement that in an implementation file like this, which would look like this eventually. It's a simple function obviously, and a client file which demos or basically executes the implementation we have done. So this is where we are calling that implementation function, but yeah, rest of the part is about preparing the input and then displaying the output and measuring the time taken and all, right? Let me try to develop that live here. So along with the problem statement and the header file, we provide a few input output test cases. So here we have provided two test cases, right? The first one is typically very simple, just like the sample test case, and the second one typically is little at least a larger test case in some cases, and in this case at least, in some cases it could cover some more scenarios or the border cases, right? So if you look at the problem definition here, the input format says so obviously this is a problem of searching for a key in an array. So in this case we are having an array of integers, and the input begins with n, which tells you how many integers are there in the array, followed by those many integers. Right? So this is how it looks like. 6 indicates the size of the array, followed by 6 integers which are part of the array. And finally the last line is the key to be searched in the array. Right? So when you search in this example, this key 1234 is present in two places, but the first occurrence is at location 2, that's why the output is true. And at this place we are going to display the time taken for execution. Right? So this number is just a representative number, but we are going to get a different number each time. Okay, so we have two test cases given here. Let's see how do we develop it. I have just downloaded not this document is here, header file along with these test cases. So these 5 files I have downloaded, and let's see, so they are here. Let's start developing the implementation file and the client file. Let's start with the client file, because that's how we are going to think about reading the input and finally executing it. Right? So I'm going to just try to implement this one. Okay, let's create this client file and then create another file for implementation. So I have created both of them here. So let's start editing them. So I'll just open them. Okay, all the 3 files I just opened. So this is the header file. So we got to implement this function, right? And this is the client file. So client file for session 1 sequential search .h, right? Or actually let's say .c. Right, and as usual I'm going to include a few of the standard header files. Okay, let's start with main function. Okay, normally I follow this coding standard where the beginning, the opening brace is at the end of the line, and the closing brace aligns with the tab indentation. Okay, so we are going to need an array, size of the array, and a key to be searched. So we'll start with the size of the array. Size of the array, and then an array itself. We could have, because we don't know the size of the array in advance, I'm going to have a pointer to the array, and then the key, right, to be searched. Alright, so I will obviously need an index to loop over. So first we are going to read the input size. So that's what the problem definition says. So scanf, we are going to need just an integer, so we'll read into this n. Then once we read this one, we are going to read n elements for the array. So it's going to be a for loop. So for I is equal to 0 up to less than n, and yeah, so here we are going to read ith element. Okay, so once we read the whole array, we need to read the key also, right, to be searched. So we are going to read the key here. So now our input is ready. We need to basically call the function to search it. So this is how the signature looks like. Let me copy the signature so that I can directly use in a similar way. So when I call this one, so this is the array which is passed, so which has the same name right now, and this is the size of the array, and this is the key we are passing. And obviously we need to capture the result in this is going to return an index, right? So integer. That index is again an integer, so I need another variable for the result. Uh, so result index, right? So it's an index to the array itself in case of successful search, right? -1 if it is unsuccessful. So now all we need to display is the location of it, right? So here is that. So we need to just display the location and nothing else, because that's what the output format is expecting, right? Don't display anything unnecessarily. Yeah, the output is also expecting the time, so at the moment let's see whether it is doing the job. Okay, let's compile. So we always try to compile using with all with warnings enabled, all warnings enabled. Okay, so normally output file I would like to generate with the name I want, but at the moment let's see what does it do. So we want an output file in this name. So I'm expecting some errors for sure. It says there is a warning here, implicit declaration of sequential search as the function, which we directly try to use, but we haven't implemented it yet, right? So that is basically, it says a warning here because it's for compiler, it's just a warning, but for a linker, this is an error because we don't have a definition of this function, right? So we need to define that one. There is one more error. It says array to be maybe initialized. Okay, that's okay. That's not a problem here. Okay. So we need to implement this one. So let's try to implement quickly and then try to use. Okay, yeah, this warning was actually an indication of a bug, right? So we try to basically read into this array, but we haven't allocated memory for that. So I forgot to do that. So once I read the input size, I should allocate enough memory for that. So it's basically an int star. So we are going to allocate n number of integers into that, so which is n, and each of them is an integer, so I'm going to take size of int. Okay, so now this should not complain the same thing earlier, right? So we just have that implementation problem. So let's do that now. Okay, we got to implement. We need pretty much the same thing to start off. So I'll just copy here. I'll say implementation file for the header file. Okay, so this is the function we need to implement, so I'm going to start the definition here. What we need here is basically loop over n elements of the array and search for the key every time. So we are going to need a looping index. So here is that. Okay. This loops over all the elements here, and every time I'm going to check whether array I, the ith element in the array, is same as the key. If it is same, we found it, and all we need to do is just return that index, right? So if we don't find it till the end, so that means it is not present, so return -1 indicating an unsuccessful search, right? So that's all is needed here. So now the implementation is ready. Here is this one. Actually we got one first warning here indicating there is in the client file it was complaining about an implicit declaration of this function, right? So why not so that is because we haven't declared it, we just used it directly, so we should be declaring that in the beginning here. So if I declare here, okay, obviously the client file or the header file name is this, so now it should not declare complain about that implicit declaration and also the definition which is a linker error because we have the definition there, right? So let's compile this now. Alright, so it didn't complain about the implicit declaration, but it is still complaining about the definition. That's because we have written that one, but we haven't given that name here. So I got to give that name also, the name of the implementation file, which is session1 sequential search.c. Now it should not complain anything about it. So what we have right now is we have written these two new files, client file and then implementation file here, and we generated an output file, right? So now if I just run this, it should just work, right? So normally we can, because we are using scanf and printf, it's going to read from the keyboard, say elements like this, and then if the key is say 423 here, it's going to say it's present at 1. But because we have given test cases, we should be reading it from the file. We don't need explicit file operations. You know that in Linux, so whenever we start a process, it automatically reads or opens 3 files. In Linux, you also know that everything is pretty much treated as a file. Even devices are treated as files, so that we read and write to the files, and that device drivers take care of the remaining part of it. So automatically it opens std in, std out, and std err. So anything scanf essentially reads from a file called std in, and that is pointed to the keyboard buffer by default. And printf writes into std out file, and that by default is pointed to the terminal for display. And std err also is pointed to display for by default. But at the moment, let's just focus on these two, std in and std out, right? So because we are reading it from keyboard, now we want to read it from the file. All we need to do is we use this indirection thing. So this less than symbol basically makes std in point to the file I'm going to give you now. So I'll give this input file 1 we are given. Similarly, this symbol greater than symbol redirects or points std out to the file I'm going to give now. So instead of displaying on the terminal, it's going to display here. I'll print it to some temporary file here, right? So it will read from the file and then it will write into the file. Actually, let's see how does the input first file look like. So I'm just going to display here itself. So it has 5 elements, and these are the 5 elements, and then this is the key, right? Because 32 is present, the first occurrence of that is in location 2, the expected output is obviously 2, right? So that's how it looked like, right? So now let's see whether our temp file is doing the same thing. It's actually doing the same thing. Now this output is very small, we can visually see that it is working fine, but it is always good to use a diff command to see whether we are getting the expected output, right? I'm using this standard diff command, which just find the diff between 2 files. So the 2 files are temp and the file I'm going to give now, output 1 file. The options mine W and capital B are basically to ignore white spaces and blank lines. So this doesn't say any difference. It's a good news. That means there is no difference. We got exactly what is expected. Right. Let's run for the second input also. So this was the first input. Let's give second input. Second input is actually much larger. It has about 1,000,000 elements in that, right? Okay, let me just show you how does it look like. Actually, cat will display it. It's too long, so let me just display the head of it. So the first line says 1,000,000. That means it has 1,000,000 integers following it. So I don't want to dump everything into the terminal. So let's we just executed it. Let's execute it. Yeah, we just executed it. Now let's see the diff of this file. Okay, diff of the temp file and the output 2 file, right? So this should match. It's also not complaining anything because we got what we expected. So if you see the output file, it'll the key was present at 500,000 and first location. Okay, so it works fine. One thing we haven't done is we haven't measured the time taken, right? So we should measure how much time we take. There is a command in Linux, say time. If I, so whenever before executing this one, if I just say time and here, so it executes that command. Along with that, it basically finds how much time it takes, right? So it says how much time it takes and all here. So this essentially means it takes about 172 milliseconds, right? But what we want is, this measures the whole thing, even the input reading and writing into files, all of that. But what we want is in this one, the client file. We don't want how much time the whole process takes. We just want to know how much time this function call takes, because that's what we are interested in. So that particular function is not going to be helpful for that. So what we need is, we want to find basically get a timestamp at this point and then find the difference, right? So I'm going to take say here this start timestamp, and similarly end timestamp, and then find the diff of those two timestamps, right? So let's see, there is one function in time.h. Let me just type it out. So I don't remember exactly what the syntax of it, so that's why I'm gonna just find the man pages of it. Clock get time is that function, so it's in time.h. Here is the clock get time, and it needs a clock ID, and it returns the time in a structure called time spec, right? And time spec structure looks like this. It has seconds part and also nanoseconds part. And among the clocks, I'm interested mostly in this real-time clock, right? So let's try to use that. So here is the start timestamp. Okay, what we need is, we need that time spec, which is a structure actually. So struct time spec start. Similarly, we need one for end also. I'm gonna just declare here itself. So we need a header file for that, which is time.h, and yeah. So let's so we just declared these two variables. Now we need to use them using that clock get time function. Clock get time, and we need to basically we need this macro, right? So I'm gonna just copy paste that macro. So then we need to pass a pointer to the structure we have for recording the time. So this will record the time, right? Similarly, we need one for end also. So I'm gonna just replace end here. So we got start and end. They are not simple integers, they are structures. So we need a little bit of finding the difference. So I'm gonna write a simple function which returns the difference in time, because it is we have nanoseconds part and all. I'm going to use double for better precision. So time diff is something I'm going to write. Time diff. So we have two functions, struct time spec. We could pass the structure directly, which will copy, but I would like to use a pointer, because that doesn't copy the whole structure, it just gets the pointer. Maybe in this case the structure is very small, but normally this is a good practice, because structures could be large EVR. Okay, so what I want is the time. So T is obviously, to start with, let's just find the diff in second part. So end. So how does the structure look like? If I go back here, we have TV underscore sec and TV underscore nsec, right? So I'm going to use that. So TV underscore sec minus start of TV underscore sec, right? This is only diff in seconds, right? But this is not all. We want the nanosecond part also. This is very coarse information, right? So we would like to add the diff in nanoseconds. So I'm just going to copy this and then replace the nanosecond part. Nsec. So right. So now we have the whole difference in time in t. So I'm going to return t. So this, I'm going to declare this in the top. because if I don't declare, it will make some implicit declaration, and implicit declaration always assumes the return type is int, so that's going to be a problem, right? So we just displayed the result. Now I'm going to display the time also, because it's a long double, so it's a double. It's LF is the format specifier for that. So time diff, I'm going to give start, and then I'm giving the pointers to them so that it just looks at the pointers and then finds the result. Okay, so let's go back to GCC. So GCC will do it nicely here, and then I got to run for input test case 1. So this is the command for that, and I got to find the diff with output 1. So this is that command. It gives you, wait a second, what did it do? That's difference in okay, the time is messed up. So alright, so we just added the nanosecond part, which we treated it as seconds, so we just have to convert this nanosecond into seconds part, and just divide by 1 billion, 10 power 9. That's going to be basically convert. So that essentially means I'm going to divide by, multiply by 0.000000001. So this will be in terms of seconds, right? Now let's go back to compile, run, and see the diff, right? So the difference is negligible because this only displays up to a microsecond level. So the microsecond level, there is no measurable number in that, and the input size is very small. Let's run with a larger input test case, right? So it took, okay, we used the time command. Let's not worry much about it now. Let's just see how much time it takes. Okay, this is still a cat command. Yeah, this is the diff command, right? So the diff, it says that it took something like so many seconds. So it's about 1.2 milliseconds. See, our time command said we need about 169 milliseconds, but the actual time needed for the core function is just little over one millisecond. So a majority of the time is spent in reading the input file and writing it to the output file. Okay, so that's why we want to use this way, because we get precisely what we need. Actually, this is not totally precise because we are just time stamping it, right? So what if within this process the operating system preempts this process and then some other process executes? In that case, we are basically counting all of the time, so it's kind of variable in that sense. And also if you are reading from memory, or if you are especially reading from say secondary disk, if it goes to page fault and stuff like that, the time is really variable in that sense. So it's not the absolute way of measuring the time taken for this algorithm, but this pretty much serves our purpose, right? I hope you understood this part. So a few more things maybe I would like to mention here is, suppose let's say here we have these files, right? So once we develop a client file or an implementation file, let's try to compile that file only. So here is that implementation file. Obviously you cannot just directly compile here, it doesn't have a main function also, right? So but we can use -c option and say compile only. In that case, it compiles and generates what is called .o file. It's an object file. Object files are intermediate files. They are binary files, but they are not executable files. So they just they just compile the functions defined in that file, right? So if there is a reference to a function where that function is not yet declared or defined, it doesn't complain about that, because that's the job of the linker, which comes later. We have a command called ld, right? So GCC uses ld for the second stage, where it links all the files. Basically, it links all the references, right? Function references. So that's how it's being done. So we could even compile the client file without developing an implementation file also, because that doesn't need the definition of the functions we are looking for. And one way to look at the symbols in these object file is to use this nm command. So this tells you which functions are there. T indicates that there is a definition of that one. Let's try to do the similar thing for client file also and see what happens. Okay, I just compiled. So now let's see if I use client.o, which is the object file. It says t main because main function is defined, and also time diff is also defined, but all other functions it is saying u means undefined, right? Even your scanf and printf are also undefined because we haven't linked it, right? So we link it at the time we need. And obviously, so our compiler understands these standard functions or standard libraries which has this scanf, printf and all, so it didn't even ask for anything like that. So otherwise, normally we should give these files in explicitly for compilation. Suppose here I gave the C file, but I could also give just the O file to compile it. It will compile nicely. In our case, even this one we are using clock get time, right? This is also, it didn't complain about this also. It's also part of a standard library which comes with time.h, right? But in some compilers it is not so standard, so they need explicit mention about that library. So for that we use this kind of thing, minus -lrt. -l indicates it's a library, and rt indicates the name of the library. So normally there is a file called librt.a. So that librt.a indicates there is a library file which has the definition of whatever the functions we need. So this is one way of providing that. Another, and these libraries are there in your path folders, right? If it is not, and if it is a user defined object files like this, so we should be explicitly giving the location of that file, right? I hope this clarifies implementation of these files. So we are essentially providing you header file, and then you got to implement client file and the implementation file. And remember to use these three commands most of the time, right? The three commands I'm going to execute once more. So not this exactly. Wait a second. Yep, this command. So this command compiles it, and the command here obviously executes, feeding the input file and then writing it to a temporary output file, and then finding the diff between the output file we got with the expected output file, right? So the difference should be minimal with respect to only the time taken. If there is anything more than this in the diff, that means the output is not matching with the expected output. All right. Okay, so in this folder I have uploaded the implementation and client file also, because this is for a demo purpose. And along with that I have few more things here. So there is one thing called test object we have written. So in this case what I have written is there is a test.c file. Now this basically replaces the client file, and it runs basically it prepares the test cases itself, and also and then calls the function which is needed here, and then tries to validate the test cases, right? Whether it got the same result. So this is basically mimicking what software developers do as part of unit testing. So unit testing is about, you develop a function and then you develop a demo program or test cases like this, which essentially make sure the function we have developed works for all possible cases, right? So it's always important to cover all kind of cases in these unit tests, so that there are no bugs in the implementation file, right? So refer to this one, you should be able to get. So obviously when you get this, normally for the students, this is a demo program, so I given the C file source of this one. Normally I provide only this object file. I just compile this one and provide this object file. So students are expected to compile this with the implementation file and run it. Let me show you that quickly. So I'll just copy the one I have in my, which is already developed. So here, let me just copy that. Okay, I don't have it here. Let me download that file, and then this is the file I want, so I'm going to download it. Alright, I just downloaded that file, and it's here, right? So how do we use this one? Suppose I have this one, and then I have just written the implementation file. So let me compile the implementation file along with the test object given to us, and write into something called I'll just say test again, test.out, right? See, I'm not using client file here. Test object is actually doing that job, because this has the main function and this has the implementation function, right? So this should compile nicely. Now if I execute this, now I have got to execute test part. Now I don't need to give any input here, because that itself is preparing input and it's automatically validating it. So when I run here, this ran for so many cases and it said passed all over the places, right? If there is any error in or any bug in the implementation file, it should catch it. Let's try to mimic one bug, small bug. Suppose I'm gonna do it something like this. Suppose if I stop, I don't compare the last element. So normally we run from 0 to n-1, so this is how it should have been at least. But if someone makes a mistake like this, so we are not comparing the last element. So this is only a problem if the key is present, if the first occurrence of the key is present at the last location in the array, we are going to have an issue. So let's see whether this catches, right? So let me compile that again. So compiled, because I just changed the source. Let me run this one. So it failed even in the base, a typical case here. But yeah, this is more like a chance. If I run again, I'm most likely I won't get that. Yeah, so I didn't get that typical error, because these numbers were randomly generated, and it happens that the key was present at the end of the array in this case. So here is the array, and then here is the key which was generated, and key is present at the end, right? So that's why this got it. Otherwise we have one failed again. Otherwise the other test cases are passing here. When I ran again, even the typical case passed, because now the key generated, random key was not present at the last location, so that's why it passed. But there is one case failing. So what does it say? It's a large input array with key present at the last location, right? So obviously looking at this one, it should be clear that okay, that is most likely the mistake we are doing, right? So any such bugs, the test module should be able to catch it, right? What if someone starts with say 1 here? Then obviously if the key is present at the first location, it should be able to catch it. So let's run this one also, right? So see, all test passed except for this one, where large input array with key present at first location, right? So instead of showing you the test case directly, we're just letting you know what kind of test case failed, right? That should give a good indication of what might be wrong with the code, and we should be able to debug it, right? Okay, so obviously let me just fix that one and then run again finally to show everything is fine. So I just fixed that, so there are no bugs in this one, and this should run nicely, right? All test cases passed. Okay, I hope this was helpful, and if you have any concerns or any issues or any questions, please let me know. Thank you.